Hello, I'm Melissa Knight. I am the Senior Analyst within the Cybersecurity Practice at IT Group. Today I'm here with Connor Callahan from Zoosk and Amaya Talwalkar from Cequence Security. We're going to be talking about API security as well as romance fraud within the dating industry. And so why don't you guys go ahead and introduce yourselves?
I'm Connor Callahan. I'm the technical lead for platform and infrastructure at Zoosk.
Amaya Talwalkar, a co-founder and chief product officer at Cequence Security.
Yeah. How have you guys seen the bot problem at Zoosk? What have you guys faced as far as bots is concerned?
So one of the issues that we see is both fake account creation and account takeover attacks.
Okay.
A lot of times these malicious actors will come in and take over an account or create a new account, then form relationships with people on the platform, and then try and convince them to send them money. Their sister is stuck in some foreign country and they need help getting them back. That's one of the issues that we're primarily concerned with in the dating industry.
So let me break this apart. So the bot will, I'm assuming using like credential stuffing or some other means of brute forcing usernames and passwords, attempt to gain access to an account on the Zoosk platform.
A lot of times what we see is from a lot of these recent large credential breaches, we see people trying credentials and then validating which ones are successful. And then they'll actually sell them through this whole niche industry underground to other people. But then sometimes we'll have whole labor farms full of people to log onto the site and talk to people. It takes a while.
This is a thing.
Yeah.
This is a very organized thing.
Yeah, it takes a while before they can convince someone to send them money. That's not an easy thing to ask someone to do.
You have to form a relationship, actually fall in love with somebody.
Yeah, and a big concern for us is that, our mission is to help people connect and to find love. And when you come onto a dating site, by definition, you have to be vulnerable. You have to be ready to open yourself up to someone. So we're very concerned about this, and we spend a lot of time trying to help people and prevent this from happening to them.
So how did Cequence help Zoosk address that bot problem, the romance fraud problem?
There are a few other things that need to happen before the fraud happens, which is the romance scam, which is two vectors by which the attackers are getting on the platform. Whether if it's an existing account, then they're going to do credential stuffing, account takeover, using all the credentials that are leaked in the underground. There are estimates of somewhere between 8 to 14 billion credentials available in the underground. And so bots are just grabbing a bunch at a time and trying them on platforms like Zoosk and others, right? So that's when you get credentials, validated credentials that you can sell underground. The other problem that we are solving for Zoosk is fake account creation, where you have bots trying to create millions and millions of profiles, eventually to build relationships on the platform and then leading into romance scams.
Yeah, I think I remember Facebook just talked about that recently, where they're discovering that not all of their accounts are actually human accounts, and I'm assuming those are bots.
Those are bots.
Those were
right.
bot-created accounts. That's very interesting. And so when people think of Zoosk, like when I think of Zoosk, I think of the website. You log in, you got your web browser. Obviously, Zoosk, I'm assuming, has a mobile app, like a lot of the other dating sites, and that mobile app communicates with APIs. What about the API attack surface? How is that affected by this? Can bots target APIs? That sort of thing. Can you talk about that?
Yeah, the bots often do target the APIs. Zoosk has two websites, the mobile web and the desktop web, and we also have an API, an Android app, and an iPhone app. So what the bots have started doing is they'll go directly after the APIs to try and create these fake accounts or validate credentials. And that's been increasingly harder and harder to protect against as bots have gotten more sophisticated, especially as you try to use client-based solutions like we've tried in the past, where you have to integrate an SDK, or you have to add JavaScript to your website. That exposes you. That software is then exposed to the client and can be reverse engineered, and that's caused a number of issues for us in the past.
I was thinking the bots were targeting www.zoosk.com. It sounds like the bots actually target the APIs. Is that an accurate statement, or is it both?
They
Is
do
it all the
both.
above?
All
Okay.
of the above.
Okay. So api.zoosk.com or whatever. I'm assuming the APIs will give them a quicker response, a faster response versus having to deal with captchas and all that other stuff that you wouldn't deal with on an API. Is that an accurate statement?
Yeah, that's correct. And it's a lot easier to program directly against an API. You don't have to make a clicker to go around the screen and type in
Right.
specific spots or things like that.
Right.
What we also see with not just at Zoosk but at other customers is when you put your security solution on the web platform, uh, the attackers quickly move to find out other endpoints, and they typically find many other API endpoints which will give you the same access, the same information as your web application. And it's sometimes, most cases, it's easier to use the APIs than the web application because it's easier to program.
How has Zoosk implemented Cequence?
So the setup we have at Zoosk is we have Cequence implemented as a dynamically loadable module at our edge. So Cequence is able to see our decrypted traffic as it's passing through.
Okay. Can you talk a little bit more about the Cequence architecture? How is the Cequence product deployed within your environment? Is it on-prem? Is it in the cloud? Is it hybrid? How do the parts talk to each other? Can you talk about the actual components of Cequence and how it's actually deployed?
Yeah, at Zoosk, we're 100% within AWS. So we have our Cequence cluster inside of our AWS environment. We have two modules that we use at our edge load balancers effectively, and then they communicate back to the Cequence cluster itself, which is what does the detection.
Okay, all right. So you guys are 100% cloud. Is it the same cloud service provider? Are you all in AWS, or do you have Azure in there as well, or Google Cloud?
We're currently all on AWS.
Okay, fantastic. So let's talk a little bit about APIs and API security there at Zoosk. I know we all have seen that news announcement about Facebook breach, and I guess they lost 50 million tokens. How did that affect Zoosk? Did it affect Zoosk? And if so, in what way?
Recently, we did see Facebook had a very large or reasonably sized breach of authentication tokens that you can use to authenticate using Facebook to a different app, such as Zoosk. Fairly quickly, we did see, through Cequence actually, that we were getting a large or a decent number of people trying to log into Zoosk using those leaked tokens. Fortunately, with Cequence, they were able to pretty quickly see that happening and help defend us against it. So it didn't ultimately impact us.
What did you guys do with those tokens? I mean, what were you guys able then to either deactivate those tokens, or I'm assuming those tokens have some sort of time to live on them, and you guys were able to deactivate them?
Yeah, the tokens are, I believe, all scoped with TTL values, and Facebook also forced password resets on, I think, around 50 million people.
Okay.
So that mitigated it, but that took a little while for them to actually do.
Now, you said actually Cequence gave you visibility into those malicious authentication attempts. What are we talking about here? Was it a massive spike? And if so, what was that like? What did that look like to the security administrator?
Well, it definitely was a bit scary to see. We never want to see a big any kind of spike like that, especially after recently seeing that breach announcement.
What did that? What was Cequence able to do for Zoosk in that situation?
So the way the product gets deployed, it's deployed, as Connor mentioned, in front of the application tier, right, close to the edge, and it's able to see all the application traffic. Therefore, we had visibility into not only their web, mobile logins, but also their API logins from Facebook. And typically, that Facebook login endpoint had a sort of a steady state profile of customers using Facebook logins. When that breach was announced, around the same time, we saw a huge spike in login attempts using that Facebook API endpoint. What that meant was those credentials that Facebook leaked, which is around 50 million, were available in the underground, and the bots got hold of those credentials and instrumented their techniques to start using those credentials on Facebook logins at Zoosk and other applications as well.
obviously this went viral. The news about Facebook's breach went viral, and it was on pretty much every major news outlet. It was on Twitter, and it gave Cequence an opportunity to provide white glove treatment to Zoosk in this case, and really assist with this spike in authentication that you guys saw. How can you talk about that,
Sure.
and what happened?
Sure. So at Cequence, we have a team of security researchers that are looking for all these events, incidents all the time. We call it the CQ Prime team. And they were aware of this news and immediately noticed that at Zoosk they are seeing a spike in Facebook login. So they worked with Connor and his teammates at Zoosk to take hold of that situation, right? Control that those attacks. But we also grabbed hold of these credentials from the underground, and we are able to now use them to match against attacks that, new attacks happening at Zoosk or at other customers who use Facebook logins.
I want to double click on the whole API security issue at this moment because I feel like it's a pervasive problem across many organizations, not just Zoosk, but a lot of organizations out there. Now, has Cequence always been the security control that you guys use to interrogate the API traffic? Or how are you guys solving this problem in the past?
So no, we did not always use Cequence. In the beginning, when we first started seeing this problem and really trying to take hold of this problem, we started playing whack-a-mole. We blocked IP addresses at our firewalls and later in our cloud WAF that we used, which that got to be very laborious and took up a number of people's time. So we started investigating the solution that our CDN provider at the time offered. That didn't work particularly well for us. We ended up going with another vendor that did client-side injection and required us to integrate it into both our web apps and our mobile apps.
What's client-side injection? Can you explain that for a second?
Yeah, so they would use either JavaScript or an SDK that you add to your app and collect different telemetry.
Sounds like a lot of friction.
It didn't, yeah.
It affects the DevOps process.
It definitely added friction to our process, and it became challenging with our Android app in particular. When you release an Android app, people don't immediately upgrade. It can take weeks for them to upgrade. And so if you're trying to make a change in the back end, then take advantage of some of the new features that are in the app, you have to wait.
So, Amaya, this whole client-side injection, JavaScript thing, is this something that all the vendors do? From my understanding, I guess Cequence doesn't do that. Does that make Cequence less effective than the other solutions? Or why this differentiator?
Right. So pretty much every other bot mitigation vendor is using client-side telemetry to make their decision whether the request is coming from a bot or a human being. That's been the technique used, starting way back in marketing, in tracking users. That's the same technique now. It's being used to decide whether a request is coming from a bot or not.
When you say client-side, you mean that this line of JavaScript that gets added to the web page?
Correct.
Or something?
It's a JavaScript that gets embedded in the page that hits your browser. The script runs inside the browser as you're loading the page and then sends telemetry back about your screen resolution, how fast you're moving the mouse, how fast are you typing, size of the screen, things like that. So it collects a whole bunch of telemetry from the device that it runs on and sends the data back. And based on those data points, their products make a determination whether a request is coming from a bot or not.
So that sounds like it could possibly be more effective than not doing that, though. But at the same time, it sounds like there's a lot of friction on the DevOps process. Developers have to insert this code in. Now, your approach is not to do that.
Sure.
I mean, do customers lose functionality with you guys because you guys don't use that JavaScript?
So I'll answer your question in two parts, right? One is why are these device fingerprinting based solutions not effective? They're not effective because they're giving away what they rely on, which is a piece of JavaScript or the mobile SDK for the mobile app, away to the users, but also to the adversaries. The attackers have these JavaScripts now in their possession, and they're reversing it and figuring out ways to defeat these these scripts or these techniques.
It's the secret sauce.
Correct, but you're giving it away, right? And what happens is, and correct me if I'm wrong, is that when these solutions are deployed, they have an effectiveness immediately after that, but it starts going down over a period of time.
So there's a decay.
There's a decay in effectiveness
That's
because the JavaScript is reversed, because the mobile SDK is reversed.
What about functionality? I mean, is it do they then does the JavaScript approach, the client-side injection approach, does that address one particular part of the attack process that isn't as quite as effective as the way you guys are doing it? Can you talk a little bit about
Sure.
the way you're doing it?
Right. So we have taken a different approach where we are using the telemetry or the signal present in network traffic at the network layer to make the same determination whether a request is coming from a bot or a human being, and if it is a bot, whether it's a good bot or a bad bot, right? All that signal is still existing in the network traffic that is generated out of the app or the endpoint. And we just run our ML and AI on the server side, close to our customers, without instrumenting the app, without giving them a JavaScript, without giving them a mobile SDK.
So you don't even know it's there. So if I were to, as a hacker, target Zoosk, I'm not even going to see JavaScript. I'm not going to know that Cequence is sitting there.
No.
You have no idea.
Yeah.
Wow.
Right, and one other disadvantage of these client-side instrumentation-based techniques is that it, as Connor said, it gets harder and harder. It stands in your way of deploying new applications or upgrading or deploying new versions of existing applications. And you're not able to protect all the endpoints.
It's a disruption in the SDLC.
Right.
Yeah.
So we talk about the monoliths being broken into various microservices. Now you have to do that instrumentation across every single microservice that you're breaking away from the monolith.
That's laborious.
Yeah. And on the mobile web also, every byte that you're loading counts. Adding additional JavaScript is just going to make your site slower.
Right. Did you guys notice a drop in efficacy?
So when we moved to Cequence, the efficacy went up.
Really?
We came from a position where we weren't having a very effective experience with the client-side injection. We had times where it was reverse engineered or various types of issues.
Wow.
So once we moved to Cequence, we were able to very quickly take care of a good portion of our automated traffic.
Do you have any information on how much of your traffic was synthetic, and then once you implemented Cequence, how much, what was the ROI as far as being able to recover bandwidth?
So looking at kind of an average week over the past year, looking at just our login and sign up and these most vulnerable endpoints, we've seen upwards of 80 to 90% of the traffic being synthetic.
Whoa! I was thinking you were going to say 80 to 90% was human, legitimate traffic. 80 to 90% synthetic.
Yes.
Bot traffic. Wow.
And that can be many
That's
millions
expensive.
of requests.
Yeah, that's expensive. You've got your, the CPU, you got the, the cloud workload costs with AWS. You've got the bandwidth costs. That's expensive.
Yeah, and one of the biggest places that most companies, I would imagine, get hit are the databases. When you're trying to validate these credentials, millions a second,
You're going to affect the performance for legitimate human users.
Also true.
That's exactly what we don't want.
What's it now?
Now we have different spikes in traffic. We still get attacks. Average week, maybe 30%.
Oh, wow.
We still do
That's
get
a
spikes.
huge drop, though. That's a huge drop.
But even blocking 90% of traffic is a huge success.
And that's at layer 3, no JavaScript, no client-side injection.
Yep.
And one final question on the Zoosk side, what recommendation would you give to security engineers and CISOs out there regarding challenges they may be facing with their API traffic security and application security? Would you, in using this technology on a day-to-day basis, what sort of recommendations would you have?
Well, I definitely recommend checking out Cequence. We've had a great experience. Everything from the openness of the platform and the responsiveness of their staff and folks like Amaya. They've done amazing things and they've been very helpful for us.
So the customer service post-purchase has been great.
Yeah, that is definitely something that, it can be a challenge with different vendors. You're not always sure what you're going to get after the proof of concept, but we've had an excellent experience.
Great. Well, Connor, Amanda, thank you for being on the show today. Thank you very much.
Thank you very much.
Thank you.